Pi is 3.14159265, but you came here for Pocket Ronnie, so please stay tuned.
Okay, we're on 19E, 6 through 8. Here it says, on the first leg of a 1,600-mile trip, Jerry, or Gary, I'm going to pronounce it Jerry, drove by himself. On the second leg, another driver helped. So I'm going to stop right there. So we have a first leg and we have a second leg of a trip. So now we're doing the scenario of, on the first leg, Jerry did this. He drove by himself for a certain distance. And then on the second leg, he had somebody helping him drive. So we're going to have this picture here of this scenario. Alright, so here, I don't know, we need to use some sort of subscripts to distinguish these two things. So how about if we just use alone? That's when he drove alone. And then how about H for help, when he had help? Or actually, I think I like the first leg, second leg. So we'll just do D1 and D2. So this was the first leg where he drove alone. This was the second leg where he had help. We do know, we were just now told that the whole trip together was 1,600 miles. Okay? So the total distance was 1,600 miles. So right now we can already make the statement that the first leg plus the distance of the second leg is 1,600 miles. We can replace this distance with a rate times time, and we can replace the second distance with a rate times time. So now let's go back to the problem to see what we're told. Okay, so then it says Jerry, when he was alone, he averaged 40 miles an hour on the first leg. Alright, so for the first leg, let's write this information over here. For the first leg, his rate was 40 miles an hour. And then it said on the second leg, the two drivers together, the two people who drove, averaged 20 miles an hour more. Okay, so you have to get that more. So on the second leg, the rate was 20 miles an hour more than the first leg. So we can now say that the rate for the second leg was 60 miles an hour. Okay, because that's 20 miles an hour more than 40. Then it also said that they drove 3 hours more than the first leg. So we'll come back to that. So the questions are, how many hours was the first leg? Alright, we don't know the time of the first leg. How many hours was the second leg? We don't know the time of that. And then what was the rate on the second leg? Okay, well we already answered that question right there. So that actually was one of our questions and we answered that. Because it told us in the information that the rate of the second leg was 20 miles an hour more than the first leg. So that's one of our answers right there. So if we go here to our formula, we see that we know the rate of the first leg, we know the rate of the second leg, we don't know the time of either one of those. So we have two unknowns, which means we have to have another equation. We have to go back to the problem and look at the information about the time to write another equation about the time. The key thing is, one of the key informations is that they drove 3 hours more than the first leg. Alright? So the second leg is going to be longer because they drove 3 hours more. So the second leg, make sure you write this correctly, the second leg time is going to be the first leg plus 3 hours more. The second leg should be longer because it said that they drove 3 hours more than the first leg. This would represent 3 hours more than the first leg. Alright, so now that we have that equation written, we can now take this, T2 equals this, we can take that and substitute it in right there. So let's put in everything that we know. Okay, we know the rate for the first leg of the trip was 40 miles an hour. We don't know T1, plus the rate of the second leg was 60, and everything is in miles an hour. So if everything is in miles an hour, then I know that my units will work out correctly, as long as all my units are the same thing. Everything is in miles or hours. So there's my rate for the second leg. So then for T2, I'm going to substitute this in right here. So T1 plus 3 equals 1600. Okay, now this just becomes algebra. I need to distribute that 60. So 40 T1 plus 60 T1 plus 180 equals 1600. I can combine things of the same kind. I can combine my T1s. 40 of these plus 60 of these is 100 of these. Plus the 180. Subtract my 180 from both sides to combine my numbers. I'm going to use my calculator just to make sure I get all my numbers correctly. Alright, 1420. And then divide both sides by 100. So my time for the first leg of the trip is 1420 divided by 100. And that comes out to 14.2, and it's going to be hours. I also can convert that 0.2 hours into minutes. What is 0.2 of an hour? If I want to convert 0.2 of an hour, I can use my conversion factors. So 1 hour would go here, minutes would go here, 60 hours cancel. So I can take 0.2 times 60 minutes, and that comes out to 12 minutes. So 2/10 of an hour, or 0.2 hour, is the same thing as 12 minutes. So also this could be 14 hours and 12 minutes. If we want to use this for calculations, I would use the decimal. But when you're going to give your answer, you can say 14 hours and 12 minutes, because this is how most people can relate. You don't tell somebody I went 14.2 hours. You tell them it took me 14 hours and 12 minutes. They can understand that. So that was one of our answers. Now we've got to find the time. That was the time for the first leg. So now we've got to find the time for the second leg. Well, what do we go back to? We go back to the equation that we wrote. We said that the second leg is going to be the first leg plus 3 hours. That was an equation we wrote up above. So now we can take this information here and plug it in right there. Okay? So, or you can use the one with already the minutes, because this was 3 hours. So our second leg of the journey would be our 14 hours and 12 minutes plus 3 hours. So you can only combine the hours to hours. So you're combining these two numbers together, the 14 hours and 3 hours. So the second leg of the journey will be 17 hours and 12 minutes. Okay, we're looking at 19E, 9 through 11. I'm just going to summarize some of this for right now. It says that there's a walkathon, and John found he could run for some of the trek. And then if you keep going, it says he walked for part of it as well. So this tells me that I had this scenario to where he started, and then he did a first leg, he ran for part of it, and then he did a second leg, and he walked for part of it. I don't know the distance that he walked or he ran just yet. So I know that I'm going to have part where he ran. So I'm going to say distance for when he ran, and then a distance for when he walked. So knowing that, then I know that the distance that he ran plus the distance that he walked is going to equal the total distance. If I go back to the problem, I can get some more information. I go back here, it says the walkathon is 20 miles. So the total distance, this total distance that he went of running and walking is 20 miles. Okay, so I know that the distance that he ran plus the distance that he walked equals 20 miles. Alright, let's go back to the rest of my problem to get some more information. If I go back, it says he walked for 3 hours. So if I go over here and say, okay, the information that he walked. Okay, so the time that he walked was for 3 hours, and the rate of that he walked was 4 miles an hour. Okay, so the rate that he walked was 4 miles an hour. Okay, so let's go see if we can find the information about run, or ran, whichever. Then he ran 2 miles an hour faster than he walked. Alright, so the rate that he ran, so the rate that he ran, was 2 miles an hour faster. I underlined the in blue because that's key words. It was 2 miles an hour faster than what he walked. Well, he walked 4 miles an hour, so when he ran, he was going 2 miles an hour faster, which means he was running at 6 miles an hour. Okay, and then it says the total distance, how long and how fast did John run? Well, that was actually, how fast did he run? That's actually one of your answers. Okay, so that is one of the answers. Then it also asked, how long did he run? We don't know that, but we can go back to our equation right here. For the distance that he ran, that's also a rate times time. Since I'm using the subscript of ran, I will use a subscript of ran here. The distance that he walked is a rate times time. And since I'm using the subscript W for walk there, then I use the subscript of W for walk here. And that total distance is 20 miles an hour. So now let's go plug in what we know, okay? We do know that the rate that he ran, that was 6 miles an hour. Everything is in miles and hours, okay? So since everything is in miles or hours, I know all of my units are good, they all match. So I'm just going to drop my units. So he ran for 6 miles an hour, and then the time he ran, that's what we don't know. I don't know that. I do know that. I don't know that. I do know that, and I do know that. So I only have one unknown, so which means I only need one equation. So the rate that he walked was 4 miles an hour, and the time that he walked, we were told, for 3 hours. So I only have one unknown. So I can say 6 TR, multiply this out, get my numbers all on one side. This just becomes algebra at this point. So equals 20 minus 12, that would be 8. And then divide both sides by 6. So the time that he ran is 8/6 of an hour. I would go ahead and change that into a decimal because we don't normally talk about the time that we run in a fraction. That even reduces. But turning that into a decimal, that comes out to 1.33333. So we could just basically round that to 1.3 hours. If we want to put that into minutes, I'm not sure if the answer just has it as 1.3 hours or they change it into minutes. So I could say that 1.33 hours. If I want to change 0.33 hours into minutes, I can go over here and use a conversion factor. Hours has to go here, minutes goes here, 60 minutes in 1 hour. So I can multiply my 0.33 by 60, and that comes out to approximately, I'm rounding, 20 minutes. So this is the same thing as 1 hour and 20 minutes. I'm not sure which answer the book has, but either one of those is acceptable.